Alrighty, friends. Let's make this key. Mrs. Key. I got the cosecant. That makes me think of sine. The +1 tells me that's where my middle is. And the 3 tells me I'm going to go up 3 and down 3. The 2 theta tells me what the period is. So if I think 2 theta equals 0 and 2 theta equals 2 pi, that's where we start and end. The sine starts on the axis, and then 1, 2, 3, 4. I'm going to call that pi. And then halfway in between, it's on the axis. And halfway in between, it's up 3. And halfway in between, it's down 3. This would be pi over 4. 3 pi over 4. Now we're actually doing the cosecant, so that means our graph is going to have vertical asymptote here and here, and then swoopy and swoopy. I did. Tangent. Tangent is sine over cosine, so I'm going to go through kind of the same idea. The -3 tells me to go down 3, which is around here, and the 2 is going to stretch it out a little bit. Let's think of the sine. So the sine, I'll do that in blue again. The sine would start here. I'm going to call this 2 pi. End here. Be here. So it's sine over cosine. So those are actually going to be on your tangent curve, because those are zeros. And then the cosine curve, I'll do that in green. That would start 2 up, and then it would go to the midline, and then down 2, and then up here. So that means we're actually going to have a vertical asymptote right there and right there, because it's sine over cosine. Alright, and then we just need to finish. So we've got 2 tickets now. Right here, the sine and the cosine are the same. Right here, the sine and cosine are opposite and the same. So that's our tangent curve right there. If you're like, how do you know they're the same? It's going to look like that. Because if you think about it, the cosine curve is going to be going like wee, and the sine curve simultaneously is going like this. Wee. So right there, that's pi over 4. They hit each other. Ooh, proofs. All right. So I'm going to do some stuff. Let's see what happens. I'm just going to rewrite the left side in terms of sines and cosines. See what happens. Sine x, cosine x. Tangent is sine over, I'm going to line things up, cosine. Cotangent is cosine over sine. And cosecant is 1 over sine. Well, that worked out nicely. So I rewrote things. Now I can cross that out, reduce that to 1, reduce that to 1, reduce that to 1. And cosine times 1 is just cosine. So I did that one. This next one, I think I'm going to stay on the left side. So tangent is sine over cosine. And cotangent is cosine over sine. I'm going to get a common denominator. So I'm going to put a sine here. Here is sine, there is sine, over here it gets a cosine. So now I have sine, cosine on the bottom. And on the top I have sine times sine, which is sine squared. Cosine times cosine, which is cosine squared. Ooh, sine squared plus cosine squared is 1. So I have 1 over sine times 1 over cosine, which is the cosecant, times the secant. I just could flip those because of the commutative property. Next one, tangent squared over cotangent squared times the cosine to the 4th is the sine to the 4th. I just am going to go sines and cosines again. So I've got tangent squared, so that's sine squared over cosine squared. And then I've got cosine to the fourth. And I guess I'm going to write the cotangent as over cosine squared over sine squared. So that's just the rewritten version of this piece times this piece. I'm going to multiply by sine squared over cosine squared. Sine squared over cosine squared. Because that makes this go away to 1. Ooh, check this out. That piece cancels out, reduces to 1. So then I have sine squared times sine squared, which is sine to the fourth. I did it. B on the right here, 1 plus tangent squared, 1 minus tangent squared. I'm going to start here. I know that sine squared plus cosine squared is 1. Let's divide everyone by a cosine, so that means tangent squared plus 1 is the secant squared. So I guess I'll replace the top with secant squared, but I'm going to actually replace it with 1 over cosine squared. I don't know if this is the best path, it's just what my brain went to. And then 1 minus sine squared over cosine squared. And I don't like that I have all these cosines hanging out, so I'm going to multiply by cosine squared here and by cosine squared here. So the top becomes the number 1. The bottom becomes cosine squared minus, sine squared. Cool. It's not the only way to do it, it's just where my brain went, so I went with it. Apparently I'm just going to stay on the left side for all of these. Actually, I don't have to. Let's use that sine squared plus cosine squared. You could do left side, doesn't matter. Equals 1. So that means that the sine squared is 1 minus cosine squared. So that means the right side here is cosine squared times 1 minus cosine times 1 minus cosine squared, because the sine squared becomes that. Let's distribute. That's negative cosine x minus negative, so plus cosine cubed x. Commutative property again, I can switcheroo those as long as I keep that negative in front of the correct thing. And I have done that one. So I did all my proofy proofs.